All right. Hi, everybody. We're here today to do a little bit of a talk about Go. We're all developers at MotionMobs, so we're all coming from it kind of from a developer's perspective. That's why I call it an intermediate introduction for into Go. So it's Go for developers. We're going to assume that things like variables and what they are and functions and how they work and all that. You've got a general concept of programming in either some other language or maybe in Go itself, but we're going to be sort of talking about a brief introduction to Go and how it all works. So, to kind of give you a spot to sort of read Go effectively and then start writing some as you get going. So, we're going to walk through a little bit of the history of Go, very fast history, short history of that, why Go is important and kind of what it's used for and where Go is used. So, we at Motion Mobs like it a lot, but so do a lot of other developers out there. And then we're going to talk a little bit about how Motion Mobs likes to use Go. So, a very brief history of Go. So, in 2007, the project was started at Google. It's a another Google language. It was started by three people: Robert Griesemer, Rob Pike, and Ken Thompson. They sort of were looking at the problems that Google was trying to solve and getting ready to start trying to solve as scale became a big deal. And so things like networking and multi-core computing, things like that, they wanted to make sure that they had a language that was ready for it, large code bases, things that the problems that Google needs to solve, they wanted to make sure that Google had a good language to solve those in. And so Go was built kind of from that. It started in 2007. Into the 2009, it was publicly announced. And then about 2.5 years later, in early 2012, the 1.0 of Go was released. Currently, right now, it is at version 1.15. I think there may be another one coming in February this month. Right now, or pretty soon. So that's the current release, though, 1.15. Why is Go important? What things do we need to know about Go as or and why we want to use it? Some key features for it. It is a fairly small language, so it's fairly easy to pick up. There's something around I think 25 or 26 keywords, so not too much to keep up with as you're learning Go. It has I prefer it that it's got strong static typing. So once you assign a type to something, it's not going to change. You also have to everything's got a type. So it's fast. It's very fast on the execution side of things. So it runs really quick and really nice. It's got built-in concurrency as part of the feature set for it. We'll talk a little bit about how to get started with some of the concurrency features of it today. But built-in concurrency means that it's ready for all the multi-core processors that are out there these days, and ready to build for that. It results in really small compiled files. It compiles down, and the files are nice and small, so you can move them around on the network really easily and work with them that way. It's multi-platform. It runs on just about everything. There's even a project called TinyGo that will run it on an Arduino. So it runs from everything from big servers to Mac, Windows, Linux. It runs everywhere. Assume that it can run on whatever platform you've got. It's got a very strong community behind it. The community really gets there's a lot of development around it and lots of packages available or modules available. There's lots of activity on the Go open source end of things. Go is an open source language, so lots of contributions being made constantly to that. It's got a good presence kind of around the culture. So, and it's got a consistent, stable API. And this may be my favorite feature of it because there are no breaking changes in any version from 1.0 to now. So if you wrote code back on 1.0 of Go, it still runs. And that has been a commitment that the Go team has made from day one that it would always run. So this is great for building stuff on the server because if you upgrade Go, you don't have to worry about your code running as long as it's still in that 1.x, 1 point whatever kind of place. So back, 2012 to 2021 now, that's 9 years of consistency where the code will run. That's incredible from modern languages, and so it's yeah, that's probably my favorite thing about it. Now we're going to talk a little bit about where Go is used. Here's a big list of all the favorites. You might see some people that you know, or some companies and projects that you might know about right here on this list, and maybe a few that you don't know about yet. I would encourage you to go look into some of these projects if you don't know about them. There's bigger and smaller projects on this list. So we've got companies like Google and Docker. Microsoft uses it a lot. There's a big Go team there. Kubernetes, you may have heard of that. Dropbox, uh, let's see, Twitch, lots of different companies that like to use it. We use it at MotionMobs a fair bit. So, and then for our use of Go, we like to use Buffalo, which is a web framework built in Go that we like to use build our backends with. We use Docker for deployment. You can write lambdas in for AWS with it, and we've done that a few times as we need lambdas to to work for us. And then we've also been working a little bit more recently with gRPC, where you can compile to multiple languages from one kind of schema definition. So gRPC has been interesting, kind of a new experiment for us to play with. But Go is one of those languages that we like to compile out to. So where to go for more info? Golang.org is the home of Go. It's a great spot to get started. There's lots of documentation, lots of other resources that they point to from there. There's a playground area on that site called play.golang.org, play.golang.org. So you can go and try out a little bit of Go there if you want to. I've used it a bunch of times to go and try some quick little idea that I didn't want to try and write the rest of the program for, and you can run it right there in your web browser, and it's really handy. The VS Code tools, I use VS Code a lot, so I can highly recommend the VS Code tools. There are other tools for other text editors that you might be using, but VS Code has really good tools. Then GoBuffalo.io is the home of the web framework that we like to use at MotionMobs called Buffalo. So check that out if you need to get started with something like that. And then I refer to gobyexample.com a lot, if especially if I've been out of Go for a little bit and I need to come back in and I've forgotten some little idiosyncrasy about it. I like to go back to there sometimes, and it helps as a quick reference for finding something about Go that I need to remind myself how it works. So, all right. So that is a quick introduction to Go. We're going to do really the meat of the presentation today is going to be about the demo and sort of how Go works and a little bit of seeing some code. All right. So now we've got our new Go project set up. I'm going to run go mod init, and that is to set up our modules, our package handling. And so now we've got go.mod file. And so now if we open up VS Code, we can go into here, and again, now we will go ahead and create our main.go file. All right, so we are in package main, and and everything in Go has packages. The file structure handles it that way, so that as you move, as you want to have exported and unexported features, functions, variables, types, things like that, you can have them in different packages and group them that way. So then you do func main. Main is where everything inside of the Go uh, process starts. So it'll run main. And then we do fmt, that's for format, print line, and hello, go. All right, so now we've got uh, our basic hello world function right here. We've got this import statement, and the import statement came in as we were adding this. So we've got fumped, fmt, often pronounced fumped, and then we can go to, or we use the print line method right there, and we print hello world. So now we've got our main.go, everything all set up, package main. If we go back to our terminal, here, actually, I'll run the terminal inside of VS Code now. Here we go. There we go. VS Code terminal. Go run main.go. Okay, so go run whatever, go run main.go in this case. Go run will run, compile and run your code. So go run main.go. Cool, there we go, and it printed like we'd expect it to. All right, so that's super exciting, right? All right, let's see here. Let's get into something a little bit more complicated. Let's start talking about variables. So there are several different ways that you can define variables in Go. You can create them that way. And then now, one thing about Go that's interesting is that if you don't use it, Go, trying to run it down here, Go, save it. There we go. Go will not compile if you don't use everything that you put in there. It's one of the rules of Go. It's part of the compiler process. If it compiles and it realizes that you've got variables or um, if you've defined things that you're not using somewhere, Go will try and prevent you from having them in there. It's I guess an optimization, or I'd call it an optimization. It doesn't know what to do with them when it's not used, and so it won't let you even compile. So a number equals 1. So there we still haven't used it, so it still won't. Yeah, declared but not used, still won't run. But if we a number. Now we can print that number, and it's good. So once we've used it, it will compile. This is one way to define a variable. You can also we'll go ahead and comment this out just to get rid of that for now. Another number. You can also do that where you just define it all in one line, sort of like you would normally do in most languages. Then we can also use what I've recently learned is the bucktooth operator for the gopher. The gopher is the mascot for Go. So the bucktooth operator lets you get get rid of the var keyword in the front and just go ahead and create and assign a variable right there. So using that bucktooth operator, this is typically what you'll see when you're reading Go or looking at Go. If you want to define a variable but don't have a value for it just yet, this is what you'll typically see, like on line 8 right here. But most of the time, you'll see this bucktooth operator right there. So that's the fast way to set up a variable, something that's uh, unique to Go in the way it looks from what I understand, or from the languages that I am aware of. There may be another language that does it as well. All right, so we've talked a little bit about uh, packages. So in Go, you can create you can structure your files however you want to. But let's say you're working with data models and things like that, and you want to have a user. So you've got a user file now. So we're in user.go right there, package. We'll go and put this in the models package. Typically, your folder names will be your packages, and then everything inside of that folder will be inside of that package. And if you get further down, you'll do, package models, um, package views, or things like that. The different sort of groupings of files are typically your folders are going to be your package names. So there we go. To set up a user, this is setting up types. Now, Go is not an object-oriented language. There's no inheritance. Um, you can't really say, okay, this inherits from this object right here. This class inherits from this object or from this class, and have sort of a hierarchy that way. So everything is a type, but inheritance isn't a concept that you have access to in Go. So when you're working with Go, you got to let go of that inheritance idea and just build as you go. So we're going to set up type user struct, and that's how you define a type right there. And structs are the way. there's not there's not another primary way to use or to set up a sort of traditional style type. Um, so and then you have fields on that struct. So let's say we have an email string, we have a password string, then we have first name string, last name string, and age. Maybe we'll do that. Yeah. So now this is one way to have it all laid out. But Go has very strong opinions about how it likes things to be formatted. There's an entire like definition of what Go looks like, and Go will, with the right tools, rearrange itself to look like proper Go. You may hear Go Fumped or Go Format, Go FMT. That is the tool that you use to format Go to make it look right, and I just used it right there. It moved these all in line with each other. If there's other kind of chaotic layout on your in your formatting, it will shuffle everything around. But the Go team has decided that Go looks like something, and Go will look like Go. So um, when you build Go, it will, or when you write Go and format it, it will look consistent with what somebody else who's written the same code. It will always look the same. It will lay itself out the same way. So when it's properly formatted. So if you do that, you can very quickly get used to reading it in a certain structure because it's set up that way. So we've got our type here, our user type. There's another feature about Go in structs that's really handy and something we use a lot, and that's called tags. And so in here, if your code uses it correctly with the tags and everything, you can look at these tags, and for when you're formatting JSON, it will format instead of the capital E here, it will format it with lowercase e. So you can set up what it will be in JSON, and then if the database fields are also structured in a certain way, you can have that defined as well right here in the DB tag. These tags are super handy. There's lots of other ways that people use them, but the way we usually use them is this. So is with these two kind of tag fields. It's an extension kind of on the struct itself. There's not like it's mostly meant for communicating with other needs for the code, things like JSON, things like database. Trying to think if I've used it in other cases. I feel like there's one other case, but I can't remember it at the moment where I used it. But uh, these tags really help uh, define what your structure is going to look like. So yeah, you can have them be different like this, or have them be first name like that, or and first name like that maybe for your database. Um, JSON last name DB last name. In this way, it makes it really easy to get the format that you want out of the different tools that you use. So if you're working on a backend and this puts it out to JSON, and so then you need to consume that JSON, you can set this up so that you can very quickly go, oh, okay, well that isn't what I'm expecting, so now I can change that, and now my backend returns that as the JSON format for this object or for this type in that field. Age DB. There we go. And so now this formatting isn't quite right, so I'll format that again and it moves it over. So there we go. So we've got our user struct. Now with that, let's see here. We can go here and we can create a method. So we've talked a little bit about our main func function. This is just the function definition right there. But we can also put methods on our types using, let's see here, using a syntax like this. So this, when you put the type in front of it, that is defining that as a method on that type. Um, and that is, yeah, this way you can use it on that type. Another thing to consider is the unexported and exported methods and things, maybe other functions inside of a package. If you have a capital letter, that's exported. That means it's publicly available outside of that package. If you have a lowercase letter, like this, that is only internally available to the models package now. So capitalization matters there on on field names, on function names, on variable names, on or variable global variable names inside of a package global variable names. Um, Things like that. You have access to them outside of the package if they are capitalized. If they are not, then they are internal to that package. So here we go, return, and we're going to return a string. There we go. So this is how we set up. Yeah, so we've got a return value here, a string. We've got our type right there with the name that we'll be using inside of the method. So return user dot first name plus user dot last. Let's see here. Yeah, user dot last name. There we go. So this will take the first name, add a space, and return it with the last name. So that is a handy feature or a handy little method that we write a lot for our types where we've got first name and last name separated, but we often want to present them together. So this is handy to have around. All right. So that's the basics of writing a method right there on a type. Go back here. We're actually going to add a function now. Here you go. Function. And we're going to talk a little bit about loops and different kind of ways to handle that. We'll talk about slices with that. Slices are like arrays, but with a Go slice. Yeah, there are arrays in Go, but they can't be uh, changed in size once they have been initialized. So slices are what you'll typically be using, and they're just an array, effectively an array that can be appended to and removed from as you need to. So we're going to work with a slice here. User slice. Now that we've got our user set up, and this is how you handle a parameter in a. There we go. Give a better name to that. How you handle a parameter in a function or in a method is that you have like you would in most language, you have the name of it, and then following that you have the type. In some languages you have the type first and then the name. This for Go, it is the name first and then the type. So we got that, and then we go, there we go. So we're going to do set up our users slice, and this is how you models dot user. And so here, there we go. And that just imported our models package right there. So we now got access to our models. This is how you use a type inside of another package. You have to refer to that package name first, and then you can use the type there. So there we go. And we've told it to set up a slice of, that's what the square brackets are there, a slice of models.user. So we got users, let's call it users, that'll be better. And then we do a for loop. This is kind of a traditional for loop. I is less than count. I plus plus. Now, with a lot of Go, the reason I was using this is just C at first. A lot of Go will have very short, uh, very short names that you're using for very short periods of time. They're, Go is not very verbose. So, contrary to other languages, Go usually will prefer, or the Go that I've seen and the Go that I've written more often than not will prefer like single or just a couple of letters, maybe three letters at times for variable names. It's a little bit messy in that way because you got to keep up with that. But luckily, if you keep things small and short, which you can a lot of times with Go, it doesn't get lost too bad. So here we go. So we're going to do that here, models.user. And to create a user, you can just do this. And I'm going to actually import another uh, package. This is a package from the internet right here called Go Fake It. It's a great tool that we use for generating fake data. So this will give us a first name. This will give us a last name. Go Fake It. Uh, Last name. There we go. All right, and if you notice, everything that we're using has that capital letter. That's because it's publicly available. It's exported, and everything like that. So then we've got our uh, U set up there, our user. And if you notice, if you hover over it, it says U is declared but not used. The tools in VS Code try to tell you that you've got problems. So here we go, users equals, and then we're going to append, which is a little bit of an interesting format here, users and with you. So rather than operating as a method on the user's slice here, we're actually telling it it's a function just that works and assumes that you're passing in a, a slice and another instance of a type. So, and then at the end, we'll return users. And this should be our return value, models.user. There we go. Yep, user. All right, let's see. Let's see if we can hurry up a little bit here. All right, so what we're going to do now with that, this will let us get a slice of users set up here. So I'm going to take, let's see, what we're going to do. Yeah, we're going to go back up here, make that a little smaller. Is that's still legible? Yeah, I guess. Yeah, go here, users, build user slice, and we want 5 of them. So this will give us a slice of 5 users. And then we can do things with it. We can go through and print. Here we go, 4. And this is another way to do a loop. This is actually working with, once you have a slice, or if you have a map, which is a dictionary or hash as it's called in some other languages, but a map, you can iterate over those as well. So this is for iteration here. User in the range of users. So this is how you do that. So say 4 instead of like 4 each. This is iterating over the range of all users in our users slice here. And then we can print line. Uh, let's do this. User, actually, yeah, we'll do print f. There we go. User dot display name. There we go. So this will now print the user dot display name. And if we run our go again, go run main.go. There we go. Now we're printing our usernames. We can do that again and again and again, and so on. That's interesting that we got the same one. Huh. Huh. Okay. Probably, so yeah, I imagine that's something with the way that Go Fake It is set up to generate. Anyway, um, cool. So yeah, so that is how we do a basic, a traditional style for loop with a certain count that we want to get to, and then another for loop using a range there. So the range is I it's super handy for iterating over a map. If you're iterating over a map, you could do for key value range my map and then do that. So that would give you the key and the value. Here, this would be the index, but since we're not using it, we can use the underscore to avoid worrying about it. and avoid having a value that we're not actually using that causes the compile problems that we've seen. Let's see. All right, other things that you can do. Something that is very important to the way that uh, Go works and Go is used is it's really good with error handling. Error handling is kind of a key part of how Go is expected to be written. When you get an error back, you're supposed to do something with it. It's not just like, oh, cool, an error. I don't really care, whatever. Get rid of it. The idea is that errors come back or errors may come back from lots of different things. And when errors do come back, you should do something with it. So by having an error come back to you, or possibly come back to you, and having to include that as part of the response from a method or a function, or the return values of a function or a method, by putting that front and center, it sort of puts you as a developer in charge of responding to it and dealing with it. And so part of the idea, or part of the sort of part of Go and writing good Go is dealing with those errors as they come back and not just ignoring them and not just trying to kind of hide from them. So we're going to now, let's see here, try and write a quick method that, let's see, yeah, I'm just going to do this. We're going to go back to our user. I've got this code ready, and so to try and hurry a little bit, we're going to, there we go, set up this sort of validation on our user. And so if we could do all sorts of other validation, but the first validation we're going to do is check to see if the email is empty. So if the email is empty, then return this error. And so we've got that error right there. And so valid, if, we'll check the user, valid email, error, and if we return nil, then we didn't get an error back, and we know that we can just keep moving. This is often how it works inside of Go, where you'll either get an error or you'll get nil. If we wanted to return another value, we could do, often you'll see this, where you'll see some sort of other value, either a Boolean or um, another type of any sort. You could have a string, you could have a user type come back. Um, False. So in this case, let's say we wanted to return if it was valid as part of that. And so this is how you do that. You have to put the values in parentheses, sort of indicate the return values in parentheses, return types there. And then when you return them, you just do that. And so now, if it's false, it's not valid. If it's true, it is valid. And then we can look at the error. Really, if there's an error, we know that it's not valid, so that's why I've started there. But if you see something where it's returning two values, you can deal with that as well. So now we've got our valid email method here on our users, and we're going to use that in another kind of example here. I'm going to go here. All right, so since our valid email method returns a value, we have to handle that. So users 0, so the first user dot valid email, we're just going to check and see if it's valid. So this is fine. We can do that. We're not doing anything with the return value, but if we get that, we can check it if error is not equal to nil. And you'll see this a lot. If error not equal to nil, you can do something with that error. We can, in this case, we can just print something saying that there's an error validating the email, and then you can actually get at the error itself. So that if you've got meaningful errors coming back, like we do here in our method, you can do something with that. You can print that out. You can return that to the user or to the if you're working on a web app, you can return it to the web app so that it can be displayed to the user. If you're working on a mobile app, same thing. You can log it somewhere so that if you're catching if you're dealing with something that's pure just backend or pure server side, doesn't have to worry about communicating back to the client, then you can log that somewhere and keep track of it that way. Um, it's handy to have it be a string because a string can be used in places for feedback. So here, we're just going to print that back out, and we're going to run it again. So make sure everything's saved. All right, good. Go run. Hey, there we go. Because we haven't put email addresses in our, where do we go? Down here, because we haven't put email addresses right there, nothing's got an email address, so we get our error right there coming back. So this is one way to handle it. There's another kind of slightly more advanced way to handle it that you might see from time to time. Users one dot valid email error not equal nil. And this is great if you got just a single value coming back. So if you got just an error or nil coming back, you can handle it this way and sort of tighten up your code just a little bit. And we'll go ahead and just do that. So this line 33, 32, 33, and 34 is equivalent to 26 through 30 right there. Um, but it's a slightly different syntax that you may come across as you're dealing with Go. All right, so yeah, so we've got that working. Let's see if there's anything else to really talk about in that before we get into some other stuff. So Go, like I said earlier, has the ability to work with concurrency really well, built-in concurrency. We're going to talk about that kind of as the finishing piece here. Go routine concurrency demo. There we go. Cool. All right, so um, this, yeah, in Go, you can very quickly spin up a new thread, a new process, a new route. They're called Go routines. You can very quickly spin one up, and it runs concurrently. It's not guaranteed to run parallel. If there's no available cores to work on, Go can't make it run any faster, but Go will try and make it work as fast as it can and use whatever resources it's got available to it to run. So you can spin up multiple threads, multiple Go routines, and have them all run as fast as they can. And Go is very good at handling that, and it's built into language as part of the concept. So Go will make that work. So we're going to do users again. We're going to build user slice. And we're going to get 3 of them, and then we're going to let's see here. Where do we do that print? Yeah, we're going to do this. We're actually going to put this into its own func print users. Let's see here. Users models user. That's not going to return anything. All right, so there we go. And we're also going to add note string. Notice a note here so that we can actually have that, so that we can put the note at the beginning. And this will help us sort of identify what happens with our concurrency here. So then we go to print users, users direct. All right, so if we run that now, that's just using the users to print them. Let's see. Oh yeah, wait. Back in the main, we're gonna run. Let's see here. There we go. Yeah, concurrency demo. There we go. To make sure we run it, we call that method at the very bottom down here. And we'll go ahead and comment out the rest of this for now. Comment that out. Comment that out. Comment that out. All right. So still say hello, but the only thing that we'll be getting now is our, or the only other thing that we'll be getting now is our concurrency demo here. So then we go, we've got that to, let's see, one way to start up a Go routine is to just type Go and print users. So this users Go routine, and that will print the users. Oop, wait, where'd it go? That's right. Let's see. Got to give it some time because it's so fast. Time dot second, give it a second to do it, and then println done. There we go. All right, sorry. Yeah, because we're doing it because we're spinning it up as a separate Go routine, we have to give the machine a little bit of time to get what it needs to done before it finishes. So here we go. We're gonna go run.main. All right, so now there we go. All right, it's really fast, but we had to give it that extra little bit of time just to do it. So that's our Go routine, running those prints out. There's also the option to do it with what's called an anonymous function here. Go func. This is a function without a name. String. Uh, let's do this. Print users. Actually, yeah, just yeah. Print line. Here we go. Message. So this lets us pass in something to this function. There we go. Pass something into this function and have it run as a Go routine as well. This is a little bit of a trickier syntax to deal with, but if you see it, yeah, you've got a function defined here. It doesn't have a name, but it's called immediately right here with this as the argument being passed into it. So in this case, there we go. And as you can see, it's further down in the code, but it runs before the Go routines get run. And I was trying to get it to earlier, I was trying to get it to run so that that anonymous function would happen somewhere in the middle of the Go routines happening, but I so far haven't been able to do that. There's probably other ways to do that, but it's sort of a race condition there. So that is how you work with concurrent the beginnings of how you work with concurrency. Now there's a lot more to learn about concurrency with Go. And that's an entire another talk to have at some other point. But there's a chance to really get in and work with. There's ways to pass data back and forth and watch out for that. Not just trigger a function, um, but if you need to get lots of things done, Go is really great because it can spin up these lightweight threads and run quickly on modern technology, modern hardware, as it needs to. Sort of back to that concept of what the creators of Go were building, or were aiming to build back when they were getting started, was getting that sort of modern hardware awareness inside of their language, and concurrency is part of that. So let's see here. I'm trying to think if there's anything else to. I think that's about it for covering kind of the basics of an intro to Go. Wanted to walk through a few different things, a few different examples, and kind of get the basics down so that you can start hopefully reading and writing some Go. If you've written Pascal case in Pascal case in that question, then it's about the naming convention or the sort of internal and exported naming convention. Capital letter at the beginning is exported. It's available outside of the package. Lowercase letter at the beginning is internal and not available outside of the package. So yeah, so that it's camel case. If it's camel case, then it is not available. Or yeah, traditional camel case where you get the lowercase letter at the front. That is not available outside of the package. You can use it anywhere else inside the package, even if it's not in the same file. So if you've got multiple models inside of the models package, you can use that internal to that package, but you can't uh, use it outside of that package. So when they get to Go 2.0, I think they've got some plans for that. They're working on it's sort of the slow process of getting there. I think has already begun, from what I understand. There's talk. There's currently talk of trying to integrate generics, which is a really kind of interesting, more modern language feature. Things like Swift and Dart and a few other languages I'm sure have generics, but generics, they've talked about integrating that somehow into the 1.x framework, and that will be interesting to see how they pull that off. But I think generics are going to be a big part of that. I don't know much else about 2.0 specifically, right at this point. I think, I'm not sure what else I want from the language, honestly. But currently, the big thing in the culture is generics. I think with modules, which are fairly new, there were other dependency management solutions before that. But in the last couple of years, probably about 2 or 3 years, modules have come on. They came on very slowly, and then kind of their standard at this point, I think. Um, Modules was a big step forward in the language, or in the use of the language and more the tooling. Um, but it may be something integrating that a little bit more. But yeah, as far as the language goes itself, I don't know what else I absolutely need from it right now. But I'm sure there's stuff that there's stuff that they'll tell us that we should have that I'm sure we'll love. Pros and cons of the language. I think it's really fast. It's really uh, the syntax of it is really nice and neat. Um, I think as far as pros go, it's some of the key features we talked about, the concurrency when you're leveraging that's really great, especially for when you're dealing with multiple web requests coming in, and maybe the system spins up a different thread to handle the different responses. That's really handy. As far as cons, let's see. Hmm, it's let's see. So I was talking about it a little bit. The concurrency is good to have. It's kind of hard. It's a different sort of structure and syntax to get into, and that's probably a challenge for it's been a challenge for me and a challenge for I'm sure lots of other people as well getting into the language. When you hear about it, like, oh yeah, Go's got concurrency, it's one of the big kind of advertising points. And then you look at it and you're like, oh, that's different. Wow, that's a different sort of syntax than. But as you get to understand it, the reasons for it work pretty well. But it's kind of a block, sort of a wall to get past as you're learning language. The it, I may have considered it a con at one point, and it may still at times. The lack of inheritance is kind of an interesting wrinkle from a language perspective because most of the languages that we at MotionMobs write are object oriented, and so you can benefit from things like inheritance, or for where you can inherit inside of a class structure and all that. And Go doesn't have that, and so you've got to build your code a little bit differently, thinking about that. Um, yeah, getting used to reading the documentation. I guess with any language, you got to learn how to read the documentation. But getting used to reading it for Go is a little bit of an interesting process, and it's not bad, but it's well documented. Most Go is, but it's sometimes a little bit tricky to wrap your head around.